An old proverb teaches that a chain is only as strong as its weakest link. Battery packs for electric vehicles have similar limitations related to performance, reliability, and safety. The sled, no, not that type of sled, consists of an array of battery modules, each containing multiple batteries in series and parallel. The battery management system must carefully monitor and control each module and battery during charging and discharging to maximize performance, safety, and lifetime. Stick around to learn more about BMS technology and components.
Welcome to Tech Chat, sponsored by Mouse Electronics, where we chat with engineering experts about the latest technical innovations that are shaping and reshaping our world. Today we welcome Jake Michaels, Technical Marketing Engineer at Pulse Electronics, a Yageo Group company. Welcome to Tech Chat, Jake.
Thanks for having me on. Excited to be here.
Excellent. So, Jake, what are you going to be talking to us about on today's Tech Chat?
So today we're going to talk about battery management systems and how Yageo Group supports the passive components into a battery management system.
Well, I'm excited to learn about it, so let's get started.
To kind of start off, we're going to look at an automotive powertrain. So we're going to look at all the systems that are electrically controlled inside a typical system. In our case, we see up to 800-volt batteries, an onboard charger, there's an inverter, converter, there's a bidirectional DC to DC charger, and all of this is in communication with the 12-volt ECU system so that we can see all of this data onto our screens inside the vehicle. So all that is done through here, but we're going to kind of cut down and focus just on that battery management system part of the circuit, which would, from the Pulse side of our organization at Yageo Group, that includes the power inductors, the common mode chokes, the Ethernet transformers, and the isolation transformers, as well as some antenna products and a few others.
Thanks for that overview. Now, could you get into some detail about the battery management systems in EVs, what they consist of, and why they're important in EVs?
Absolutely. So to focus on battery management, there are large battery packs that are in these vehicles. They're made up of thousands of individual cells linked in series. These cells are arranged in a module and then a module into a pack, and which is commonly referred to as a sled. And those are rated in kilowatt hours converted to the range. So if you have a 23 kilowatt hour 5-module system, which consists of 86 cells or 430 cells at 320 volts per meter, that's about 120 kilometers you're going to be able to get out of that pack. If you were with an 85 kilowatt hour 16 module system, you would be able to travel 350 kilometers. So the sled really determines the range of these vehicles, and its job is to store DC voltage and current that's converted into AC to drive the motor through that inverter converter. And then these battery packs are linked in series. They all need monitoring and controlling. So that's really where our battery management system comes into play, is the charging and discharging of these battery packs, because you can't just let them charge unbridled. That can be hurtful to a cell, and if you let them discharge the same way, that also can be detrimental.
That's fascinating. So, Jake, you've explained why BMS circuitry is so important in EVs. Could you give us some insights into what are some of the main modules in a battery management system and what roles they perform in a BMS?
Absolutely. So a battery management system is broken into basically two parts. There is a cell monitoring controller, which monitors the real-time cell voltage and temperature. It also acts actively and passively to cell balance. As things are charging and discharging, it's trying to make sure that all of the cells are charging and discharging at the same rate, and that no cell ever reaches 100% and no cell ever reaches 0%. We never exceed those limits in order to preserve the life of that cell. The other hand of this system is the battery monitoring controller, which collects all of this data from all of this monitoring that's been going on and communicates that with the vehicles in the central network. It displays your battery health, your charge status, and the temperature to the user on your end.
Excellent. So now that we have a good understanding of EV BMS and how it's in its key modules, could you talk about how these BMS components are implemented and connected in EV? In other words, how the different subsystems communicate with each other? How do they link to each other?
Absolutely. So each one of these battery packs acts as a slave in a master-slave configuration communication-wise. And each one of these, there is an isolation transformer or a common mode choke in line so that any of the noise caused by one of these slaves doesn't interfere with the rest of the system. This is all fed back through a couple high isolation transformers and then back to the master BMS controller on an Ethernet system. They all communicate on one serial communication bus, and we try to daisy chain them together so that we can create the shortest path and the least cost. And then that security protocol is done through SPI or SafeTI or however the data is transmitted across the bus. This bus needs to be isolated in order to stay independent, because there's a high potential difference from the battery packs to the chassis. And so this is somewhat of a dangerous setup if not isolated properly. So the transformers are chosen for coupling circuits over the capacitors because they have a high working voltage and a large creepage clearance distances needed to fulfill the safety and industry standards. And so on top of being ACQ 200 qualified, these are all PPAP and ISO 16949 certified. So it's a balance between cost and safety because we are dealing with a lot of power in these battery packs, but we also want it to be roadworthy as well as safe for the end user.
That's really interesting. So now let's talk about products. So let's talk about the Pulse Electronics products that engineers can actually use to design their battery management systems.
Absolutely. So from the Pulse branch of Yageo Group, they offer a wide range of products specifically for battery management systems. So their power inductors and their SMP transformers are used in the DC to DC inverters and converters and the onboard chargers, as well as the wall mount units. They have high isolation, high voltage BMS transformers, which we talked about earlier, Ethernet and PLC transformers, EMC common mode chokes for CAN and SPI. And then, of course, if any of these systems needed to be communicating wirelessly, there's wireless products specifically designed for BMS communication in a vehicle. So all of those antenna products that are associated with legacy Pulse.
Yeah, that's awesome. Like, I know one thing, our All About Circuits readers love circuit diagrams, so they love this stuff, and it's good to know what's available. That's a very impressive range of products that engineers can use for their BMS design, so thanks for that overview. So while we have you with us, Jake, could you tell us what kind of other power conversion components are available from Pulse Electronics and Yageo Group?
Absolutely. So shown here is a power converter that covers all of the Yageo Group products. So this would be being controlled by the battery management system. All of that data that the battery management system is collecting and using, this is how it effectively balances those cells. It actually controls the transistors along this circuit in order to charge and discharge the battery, because this is a bi-directional circuit. So this happens forward when the battery's charging and in reverse when it's trying to power an AC motor, for example. So from left to right, Yageo Group covers all of the products shown here. So the safety caps, whether they're a film, the common mode chokes, the AC harmonic filters, as well as the circuit protection components on this EMI filter stage, the metal oxide varistors and gas discharge tubes. If you move into the power factor correction stage, there's PFC inductors specifically tailored from the Pulse side of our business, current sensors that are detecting the current on all of the different lines, power resistors that are working with the DC link capacitors, so which are either an aluminum electrolytic, a film, or a ceramic. As well, again, there's isolation transformers, which we talked about before, and then the snubber capacitors. Moving into the DC to DC stage, we have the isolation transformers and the current sensing transformers as well. Snubbers, the resonant capacitors, which are denoted as CR, and of course the power transformer in the center there of that DC to DC stage. And then last but not least is it like an output inductor and then an output ceramic or film capacitor to do that last little bit right before we put it into a battery cell. All of these products are available for purchase at Mouser.com. And then this document and this circuit diagram is actually a downloadable interactive PDF that you can use, and as you drag your mouse along, you can use it to identify what products and parts, and if you click on the component, it'll actually take you to the website to look at the data sheet for that specific product.
Jake, tools like this are really what engineers really love these days, and like to see everything put into one circuit diagram and linked up to components is fascinating. So Jake, this was a very educational discussion about the technologies and components that go into an EV battery management system. Before you wrap up, Jake, are there any key takeaways that you'd like to emphasize for our Tech Chat audience today?
The one key takeaway I do kind of want to talk about. So Yageo Group offers about 90% of all the passive technologies that you can see in electrical engineering. And so we are just want to express how much of a one-stop shop we are because of this. And especially in the automotive space, a lot of our parts are AEC Q200 qualified. And so we want engineers to know that we support them in all of their endeavors. And that, again, we are a one-stop shop to your passive needs.
As we wrap up today's Tech Chat, we want to thank our sponsor, Mouse Electronics. If you're looking to purchase any of these great post electronics products or other electronics components and supplies, I would encourage you to head over to Mouser.com and also thank them for supporting educational presentations like this. And please join us next time on Tech Chat, where we chat with leading technical experts like Jake Michaels from innovators like Post Electronics who are changing our world every day.